In this video, we're going to do a quick recap of the different types of chemical reactions that you learned in grade 10. We'll start off with the simplest one, which is called a synthesis reaction. Synthesis really means to make, to build, to put things together. You take two smaller things or many small things and you put them together to make a bigger thing. So let's try an example here. We'll just do sodium plus chlorine produces NaCl. Two things coming together to make one larger thing. We could do H2 plus O2 produces H2O. Two things coming together to make one larger thing. That's a synthesis reaction. The opposite of that is to break. And when we say we're breaking, we call it a decomposition reaction. So it's the reverse of what we saw above. So I could just take the NaCl, use some energy to break it apart, and I get Na plus Cl2. One big thing becomes smaller parts. I might have H2O, put some electricity through it, and it will become H2 plus O2. You had one bigger thing becoming two smaller parts. So synthesis and decomposition are essentially opposite of each other. Let's do a more example actually you can try to identify this as either synthesis or decomposition. So here I have calcium carbonate. I'm going to heat it up. Instead of writing heat, I'll put a triangle. That means heat in chemistry. And it's going to become CaO, so calcium oxide plus CO2. So you have to tell me if this is a synthesis or decomposition. As you can see, you have one compound becoming many smaller ones. So since you broke one thing down into many smaller parts, you have a decomposition. Next, we're going to take a look at our displacement reactions. The first type we're going to see is a single displacement reaction. In a single displacement reaction, you have a single element that's reacting with a compound, and that element will kick another element out of that compound and just leave one new element alone, and the element that was alone before will now have a partner. Let's just take a look at what I mean by that. So let's have we'll have Na plus CuCl2. Elements alone reacting with a compound. The Na will kick the Cu out, and now the Cu will be alone, and now the Na is with the Cl. This is a single displacement because at the end, something is still single over here. You might also see something like this. So you might have Cl2 reacting with NaI. And in this situation, the Cl will kick out the I. Now the I will be alone, and the Na will be with the Cl. So in a single displacement reaction, you have an element that was alone, switch spots with an element in a compound, then you'll end up with a new element alone, and that element that was alone before is now part of the compound. So they switch spots, single displacement. That's a little bit different from a double displacement. In a double displacement reaction, you have two compounds reacting, and in those two compounds, two elements switch spots. But at the end, no one's single. Everyone still has a partner. So for example, you might have NaCl plus Ki. The Na and the K will switch spots. So K will go where the Na was and be with KCl. And Na will go where the K was and be with I in NaI. So this is called the double displacement because it was two compounds reacting. And at the end, you still have two compounds at the end where nothing's alone. It's just that the two things there switch spots to be with different partners overall. And that's called a double displacement reaction. So you can try to identify the following displacement reaction as either double or single. So look carefully. You had a single element. Looks like it kicked out the silver there. And now silver is single. And you have a new compound there. But you still have something single here in the end. So because you still have something single, this is a single displacement reaction. And lastly, we're going to take a look at our combustion reactions. Combustion reactions are fairly straightforward. They're always kind of the same thing. For combustion reactions, you have two main types. You have complete combustion, and let's just call that lots of oxygen, lots of O2. And then incomplete, which is not as much O2. So I'm going to show you complete first. That's when you have something called a hydrocarbon, which is basically a compound with lots of carbon and hydrogen. So it doesn't really matter what it is. It could be CH4. It's going to react with O2. If it's a complete combustion, if I tell you there's plenty of oxygen or sufficient oxygen or lots of oxygen, then your only two reactants or products are going to be CO2 plus H2O. It doesn't really matter what the formula is. So even if it was C3H8 plus O2 and I told you there's lots of oxygen, there's sufficient or abundance of oxygen, you just have CO2 plus H2O. And then we typically say plus energy because there's energy released here as well. But you might not always see that written out. CO2 plus H2O for complete combustion. Incomplete combustion is when you have a little bit of O2 present or not enough O2 present. So it's insufficient O2, we say. Insufficient O2. Insufficient O2. Or I'll tell you there's not enough O2. You start off writing it the exact same way. So I might have CH4 plus O2. I'll tell you there's not enough oxygen there. So you'll start off writing the same products, CO2 plus H2O. But now, because it's an incomplete combustion, there's these other products made as well. You have just carbon, what we call soot sometimes, SOOT, plus the deadly toxic carbon monoxide. And so that's the main difference. I'll tell you it's not enough oxygen. You'll write the regular ones like in complete combustion, plus these additional products there. It doesn't really matter what the main starting formula is. So C3H8 plus O2, I'll say you had insufficient oxygen, and you'll say, okay, well, that means just CO2 plus H2O plus C plus CO. And that's it. So I'm going to write out an equation, and you have to tell me if it's a complete or incomplete combustion. So we'll do C4H10 plus O2, and I'll say it makes CO2 plus H2O. So notice that I didn't tell you if you had enough oxygen, but I gave you the products, so you could tell me if you had enough or not. So based on the products CO2 and H2O, we know we're dealing with complete combustion reaction, because in a complete combustion reaction, you only have CO2 and H2O produced. If I had given you this instead, C4H10 plus O2, and then I wrote CO2 plus H2O plus C plus CO, you would have known that's an incomplete combustion and insufficient amounts of oxygen were present in that reaction. And so far what we've seen is that there's many different types of chemical reactions that can occur, and we can identify them based on patterns in their reactions and their equations. So we saw synthesis to make, decomposition to break, single displacement where one thing switches spots with something else in the compound, but something's still alone or single in the end. Double displacement where you have two compounds reacting and two things switch spots, but at the end of the day, everybody's still in a compound and no one's single. And then we saw combustion reactions where you basically burn something with oxygen. You use oxygen as a main reactant to burn it. And we saw that there's complete, which has CO2 and water produced only, and then incomplete, which has CO2, water, carbon as soot, and then carbon monoxide, the deadly toxic gas, produced as well. There's one more type of reaction that you may have heard of as well called a neutralization reaction. That's actually a special type of double displacement. It's a special type of double displacement. It's a reaction between an acid and a base, and it produces salt plus water. So an example of that would be if you had HCl, which is hydrochloric acid, reacting with NaOH, which is a base, sodium hydroxide. It's a base because it has OH there. And then what will happen is the H will kick the Na out, and then the Na will go where the H was. And so you'll get NaCl, AQ. Well, you don't have to put AQ right now. I mean, you do, but right now, don't worry too much about it. NaCl. And then when the H goes with the OH, that's HOH. HOH, if you look carefully, is just two H's and one O. That's H2O plus H2O. So this is a double displacement reaction between an acid and a base. It gives you a special type of double displacement called a neutralization. The reason we call it neutralization is because when the acid and base react, the resulting mixture will no longer be acidic or basic usually. It's going to be closer to neutral. Quick recap there. Acids usually have a pH that's less than 7. Bases have a pH that's more than 7. After the neutralization reaction, your pH is going to be closer to 7. It might not be exactly right on 7, but it'll be more neutral, closer to the 7 mark. And that's why it's called a neutralization reaction between an acid and a base. Looks like a double displacement, but again, it's a special type of double displacement between acid and base.